I'm going to start very soon. My topic is about capturing streaming media, actually capturing web streaming media. By web streaming media, I mean anything that you can find in internet using your web browser. So we try to capture that, or in other words, we try to download streaming media like video and audio. So we do not cover things like Spotify apps or iTunes. No. Okay, everyone, have a seat. Okay, first of all, I would like to introduce myself. I'm Neo. You can call me Neo. I'm an RPA developer. RPA stands for. Does anyone know what RPA is? Yes, correct. Robotic Process Automation. That's my main thing. So I deal with automation all the time using UiPath and Work Fusion. I'm also a programmer, mostly using Python, PHP, and I do some front end. And I honestly don't like it. It's a hard thing to do. Okay. I work in a media monitoring agency. It's called media monitoring because we monitor traditional and conventional media like TVs and radios and some social media too. Apparently, I'm also digital comic artist at relevant. So if you're not interested with this talk, so you can open your Instagram or Facebook. You can just type in at relevant. It's okay. It's okay. Just don't run away. Okay. Moving on. Before we try to capture that, first we want to understand how it works, and loosely, like we try to reverse engineer that the streaming that they send us to us, instead of just stream once, view once, instead of that we will keep it in our local folder for research purpose. Okay. So how web streaming works? Okay, in an ideal world, web streaming is just like any other file transfer in the internet. So you make a request to the server. You are the client here. You make a request to the server, and then the server will give you a response. For example, you want to watch something like Avengers Endgame, so the server will give you that. Take this file. But wait, there's more. Okay. In a less ideal world, like the real world we're living in, so when you make a request of a video or audio or any streaming file, instead of giving you the media file, they give you something they call playlist. Okay, also called manifest. This is not the manifest that JSON, for the web developer. This is a different thing. So the playlist actually contains the smaller of the file, streaming file. They cut it into smaller fragments. So they give you the list, and you're like, okay, you're gonna request this list of file, and then it's back to this again. Retrieve the media file. Okay, so they may call it fragments, they may call it segments, they may call it parts, but it's the same thing. It's a part of a bigger file cut into smaller pieces. But wait, there's more. Okay, what about live streaming? Okay, I mentioned before the manifest, the playlist file contain a list of fragments of the streaming. But list means something that is finite. Okay, so for a movie, maybe they have 1,000 small fragments, but it's still finite. But for live, it's not finite. You don't know when it's gonna end, so the list will go on and on and on and on. So instead of giving you one playlist, they may send you multiple playlists one at a time. So let's say they send for 5. It's okay if I'm walking around. They send another 5 seconds like that. and then you have to process again. You go back to the you treat each playlist file like this one, but now you have a multiple playlist. Don't worry, after this I will show you how it looks like. Okay. I will reverse. So there are multiple standards that they use to stream. The most popular one is called HTTP live streaming or HLS, and the second one is called MPEG-. There is also other standard, of course, but this is the most popular one, and the HLS is the one that you are most likely going to see. Okay, it was developed by Apple, and MPEG- is developed by MPEG. MPEG, I think it's like a consortium of powerful people or something like that, or they decide what's the standard. I don't know. Okay, so 95% market share, mostly you're gonna find this in HLS. 10% market share is MPEG-. I think if you sum up, it's more than 100%. Okay, why? Who can answer that? Sorry? Number from different time. Probably, but there might be some. Okay, but more accurate answer, anyone have it? Okay, come here. I give you. Okay. Okay, thank you. Some service provider, they give multiple protocol. They use multiple protocol. Why? The thing that you can see from this is that HLS is developed by Apple, MPEG- is developed by someone else. So in reality, all devices can play HLS, but MPEG- there are certain devices that cannot play, and you can guess what is it. It's the Apple device, of course. It's proprietary, so they cannot play, right? So it's your business, okay? But so some service provider, they give in both or many other standards protocol, just to make sure that they have the widest coverage of audience. But other than that, the delivery is slightly different. HLS send you a playlist file .m3u8. Okay, M3u. If anyone has ever used a Winamp, so they remember playlist file .m3u. I still use it until now. It's actually a list of file. That's the definition. The playlist is the file that contains playable media. And 8 stands for UTF-8. It's the internet, so it makes sense if you see that. This is just the same thing. It's just a updated version. And MPD, that's manifest. That is a file. Instead of sending you an M3U8 file, they send something called .mpd file. This is like an XML. So it's slightly more complicated, but thankfully we do not cover that today. Okay. Okay. So to recap, media streaming. They are single stream, meaning that they give you one single stream. So this is simple to cater. But sometimes they give you fragmented streaming, fragmented file, the one that I've shown before, using playlist. So there are protocols that they use, maybe HLS, maybe MPEG-, maybe some other types. Okay. After this, I will give you the slide, so you don't really necessarily need to take pictures. But if you want to take my picture, then it's okay. Okay. Oh, but wait, there's more. For video streaming, in an ideal world, they send you one stream. It's called multiplex. Multiplex means a file that contains both video and audio. So just like a file that you have some videos.mp4, okay, that's multiplex. There's only one file. Okay, but actually there are streaming that send you multiple file, one for video, one for audio. Okay, so we have to treat that with special care too. Other than that, as you can see the name here, adaptive streaming, actually both HLS and MPEG- is adaptive streaming. Adaptive streaming meaning that it will adapt to your network condition. If you have a good network condition, then you will saw a more high quality file. If you have not so good connection, maybe you will see like, I don't know, 360 or 240p, something like that. So I think you realize this already in YouTube or any video. If you have a slow connection, then the streaming will adapt to your current need. Both are actually adaptive streaming, but if HLS put the name also adaptive streaming, it's quite confusing, but it's the same thing. Okay, so now what we are going to do with that? Now that we understand, not really understand, but we see the brief idea of the streaming media. Okay, so what now we are gonna plan what we're gonna do. Okay, take example, we have a single streaming file, let's say live radio. Okay, so it's endless. In theory, it's endless. So we're gonna receive that streaming, we're gonna divide it into smaller chunks. Okay, and then chunks by chunks, we're gonna stitch it together to form a file in our local or anywhere that we want. If needed, we're gonna convert that. If needed, if not needed, then it's okay, you can use it already. And then we have our final product. But this is for the simple one, which is quite rare to find. And this is an example of playlist file. It looks exactly like this. We can read the header, hash key, x key, m3u, that's the headers. Version, playlist type. There are two playlist types, VOD and something else, but this all doesn't concern you really. Target duration is the maximum length of each of the chunk. Okay, from the first look, okay, we can actually see, we can actually filter out which one is the playlist, which one is the playable media, and which one is just rubbish. You can just throw it away. So you are a Python programmer, so naturally you will see that start with an hash is a comment. It's just a coincidence. Okay, so start hash, we're gonna filter out. What's left is just the playable media. So we're gonna extract this file. We're gonna read the playlist. We're gonna filter out which one is a playable streaming media. I'm gonna stitch it. But first we have to read it right. And with Python it's very easy. But what if we cannot find the playlist, or we don't want to use the playlist, we just want to directly from the source, we know the file name. So one thing you should notice is that the stream that will be given to you is actually incremental 1. So fragment 1, fragment 2, fragment 3, fragment 4, until whatever it is. So instead of reading a playlist, what we gonna do, we can also for each of this fragment, we're gonna send a request. We're gonna read the header, response header only. Okay, if the response header is something like audio/mpeg or video/mpeg, something like that, and it's a media file. If we exceed the number, let's say that there are 200 fragments, so when we reach fragment 201, 201. What do we get? 404. Final found. Right. So what do you expect the content type of that response? If there's a page, there is the dinosaur, that's one thing. That's one thing, the dinosaur say page not found. So there's no response, there's an error. But there are also the service provider that actually cater this. If there is no file, then they give you a found page. That one is text/HTML. So you have to be careful with these two things. So what we need, of course, Python. This is a PyCon, so we don't talk about Python. We're gonna use one library, very famous one, request. I think almost everyone have ever used it. Anyone never used request? Wow. You use, okay, everyone use request. And then FFmpeg is a utility that just to convert file. It is not necessary, but if you need to convert that, you can use FFmpeg. FFmpeg is a library that, like a wrapper of the FFmpeg to make things easier in Python. So this is it. This is all we need. Okay, you can install request FFmpeg, and if you use Windows, then you can download FFmpeg at that page. It's up to you. Okay, but to use FFmpeg, you need to install FFmpeg, and you will not regret that. FFmpeg is very powerful. You can convert any media file. Okay, later on you can check if you want to try it out. It's very simple. You can check it on my GitHub. What we're gonna do is, first one, extraction process for each of the streaming media. Okay, this one very simple. Let's say we have the source URL. The URL contain the streaming media, and our output file. We decide the chunk size. That one is depends on you, or the internet connection, or the server. It depends. So we go through the function here very good. This is extract, but you cannot see it very well. extract is up to you. Okay, we open the output file. This is a good thing about Python, that we can go line by line very easily. Okay, open file AB. What is AB? Come on, Python. Yes, correct. A for open, B for binary. I'm sorry, I didn't have any more gift. So, but it's correct. Simple. This is what I love about Python. AB stands for open binary. Okay, so we make a request here, source URL, stream true. Okay, this is an option in request. By default, is stream false. The difference is that when you set it to stream true, okay, for this request, the request library doesn't wait until the file ends. Keep on coming. So I set the stream to be true, and I set the timeout. Timeout is the limit where if we don't have any response from the server, we want to cut it off. We have to do that because we cannot wait forever. So for each chunk here, in our response, like iter underscore content. This is great. Iter underscore contents mean iterate content. That's it. I'm sorry, we can't get any simpler than that. You're gonna iter each of this one, into the output. So you see, it's very easy. It's very simple. But what about the playlist? Now we're gonna read the playlist, like here. And we're gonna filter out all the other things and just get the playable media. So to do that, in our function, we're going to read line and content. This one we set the string not to true, string false, because It's a playlist, it's finite, so you just can get the file and it's done. For each line, this is beautiful, very beautiful. We want to filter out each file that that start with if we start with a hash, we will filter out. So in Python, we just write the first, because string is just a list of character, right? So if the first character is not hash, then we're going to extract using the previous function. It's very beautiful. And then it's a delay. Okay, this is like a intermediary between each of requests that you make. So we want to put a slight delay between each of these. So 1, 2, 3 fragments. I'm going to put a small delay. Why? Because we do not want to hurt the server. We don't want to hammer the server. Actually, we are trying to emulate what we are doing with the browser if you are viewing a streaming media. So there are like the time. If you watch YouTube, then the loading bar, we wait, and this is loading just slightly forward of what you're watching right now. So there's a progress. So we want to emulate that. We want to show the progress. If you didn't put it, it shows some. For if you have 500 fragments, it's a very short intermediary between each file. It's realistic, and the server may detect you like a boot attack, something like that. So that's not like you have a very unrealistic request. And then, okay, for multiplexing, multiplex means to combine video and audio into one file output. This is simple, as simple as this, using FFmpeg. What you're seeing here, this is the compression that we're going to use. Actually, you can just put none, meaning no compression. Okay, the file will be big, but this one takes time to compress process, but it's up to you. And then we run it. This one is very simple. Doing this because when we have a good supply of streaming data, by this I mean the audio and video, we can focus on the next thing, which is a lot of speakers are talking about, even the analytics, language processing or whatever it is. But I'm just gonna talk about capturing the streaming media. Oh God, it's time for live demo. I was actually advised not to do a live demo, but this is a PyCon, right? And I also like to live on the edge, like right now, standing on the edge. I'm gonna do a live demo. Hopefully it's gonna work. If it's not gonna work, this is probably the last time you see me in PyCon. Next PyCon, but maybe I wear something like tudung or you won't recognize me. Okay, let's try a simple one. Okay, I built a Dailymotion downloaded. You can try it. So let's say I have a Dailymotion. I go to a Dailymotion. Okay, and this is PyCon, so we're gonna try to look at the multi-Python, of course. For example, this one. So you want to inspect that. To inspect, you have to press Control Shift I. If you are using Firefox, you also have to press Control Shift I. If you're using Internet Explorer, but you need to consider your choices. Like, why do you use Internet Explorer? Okay, so this one, if I refresh it, so we want to see the playlist file. Start and key U. So you can find here on the network. This is the playlist file I'm talking about. It looks exactly. Sorry? That's cool. Yeah, that's cool. Thank you. This is the playlist file I'm talking about. Okay. There might be slight variation, but the core is still the same as the header and the list. So now our simple script, what it will do is we're going to filter out, interpret that, just like we have spoken before. Okay, I add something that is a header. I don't know if you can read or not. It's a header. This is the header that we send to the server, because we trying to tell the server that we are not using Python as to download that string file. We are actually something browser. Lying. This is called strategic misinformation. We provide inaccurate header to avoid okay, we lying. Okay. So, we send the header just like I told before. I should not do a live demo, but you only live once. Okay, just like in the slide, you're gonna read the playlist and interpret the playlist. You're gonna convert that into MP4, because what we received is actually .ts file. .ts is a wrap for streaming purpose. So we're gonna convert that and we're gonna remove the temp file, and it's finished. So now let's pray together that it's gonna work. I'm gonna put the playlist URL here, file name, whatever, MultiPython. So you see, we are extracting each line in this playlist and stitch it together. It's doing that depending on the length of your file. So you see that extraction is already done. Now it's converting using FFmpeg. You can actually see this. This is the TS file that we received. We can actually view it. But it's like laggy, something like that. It's slow load. But we want this one. This is being big. You see, 48. But this one is okay. Now we've process finished. That means this streaming video here is actually in our local. So let's take a look. I think maybe most people have already watched this. You gonna watch the full video? It's okay. Okay. So okay. I waste your 2 minutes, something like that. This is an example of very simple script using Python just to convert the streaming file into a playable media on our local. Okay, next, because we still have some time, we're gonna try to, quite ambitious, we're gonna transcribe a live radio in almost real time, just using Python. So this is our source here, is BBC Radio 4. So if you wanna listen to this, this is the radio. I hope it works. Okay. It's a British radio. So what I'm trying to do here is we're gonna read that streaming and convert it. We're using pocket strings. Pocket strings speech recognition is for developed in CMU in US, I think. is not as accurate as say Google Cloud Speech API, but Google Cloud Speech API is not accurate to my bank account. It's quite pricey. It's quite pricey, and by quite pricey I mean it's very expensive. So imagine if you wanna analyze the whole 24 hours radio, one channel, usually there are like 10, 20 radios like this. Simply you're going to be bankrupt very soon. So now I'm gonna just briefly show the code. This is still the simple things that I showed earlier. Okay. The convert, okay. The main function here, we're gonna read the source. I'm gonna put it in the smaller chunk, and we're gonna convert the smaller chunk into wave because speech recognition doesn't recognize MP3 as an audio file. They need to convert to wave first, and then after converting to wave, I'm gonna transcribe it. Okay, so we're gonna try. Okay, so this is okay. That's good. This is almost real time in BBC Radio 4. It's not gonna sing perfectly with this one, but this. As you can see, the sentence doesn't make any sense. See that in the can no longer to pair with drugs in my life, or what is this one? I just want to show you what we can do. You should use a better speech recognition like Google, okay? But it's in almost real time by PyCon, and it's very simple. You can write this code like in 5 to 10 seconds. It's just an exaggeration, but you get the point, okay? Very simple to use. Okay, with that, if you are interested, you can go to my GitHub and check this project. It's for fun. Okay, that's all. Thank you.